Hello. Now we'll be talking about an A/B experiment. So, what really is A/B experiment and what's the need for it? In software development, and specifically when you talk to product folks, they will always talk about A/B experiment, and this is a very standard way in which you can essentially roll out multiple versions of a product or a feature and are able to verify if these changes are actually helping you achieve those business objectives with which you made these changes in the first place. And that's done through a technique that's called A/B testing. So let's take an example. Now, typically in e-commerce websites or in any other websites uh, where they want to drive a particular user behavior, they would end up changing the user experience in such a way that it drives a certain behavior. For example, making it easier to check out the products or making it easier to consume content on a content networking site, right? So those are the cases, right? And what the way it is done is that you typically have something called as a baseline that already exists, or is your baseline hypothesis and the product that is already available to a user, right? And then when you want to change this behavior, what you do is you start with some experiments that, hey, what if we change this button from, let's say, blue color to orange color? Will it, for example, drive people to check out more as compared to the blue button? And then you expose a certain sample of your users with the new variant that you want to experiment with, and you run this experiment for a certain period of time, maybe couple of weeks, couple of months, depending on the use case and the actual experiment. And at the end of this duration, what you would do is you would compare the results of the control group versus the baseline group, and then you would see if there is any difference in the user behavior, and if this difference is actually what you wanted to encourage in the user behavior. And this is how an A/B testing is done. So essentially, it's a controlled randomized experiment that establishes causality. Now, causality is important because even if you talk about machine learning models or anything in product in general, right, you have a business objective in mind that, hey, our users should be able to, let's say, check out faster. There should be fewer dropouts during the checkout process, or something similar, right? So that's the business objective. That's what you take as your North Star, and this is what you want to drive the user behavior towards, right? And then you define your overall evaluation criteria, which you can think of as a proxy to your business objective, because sometimes business objectives can take many months, if not weeks, to actually be visible, right? So what people typically do is define an evaluation criterion that is a proxy to the business objective, and use this as a metric to see how the experiments are performing. So going into how an architecture look like. So first of all, you need to define your experiment parameters, which includes the sample size and the duration of the experiment. Now, in order to come up with a reasonable value of sample size and duration, there are two key parameters that you need to think upon. Number one is called the power, which essentially is the probability of a false negative, and then there is a thing called as level, which is the probability of false positive. Now, ideally, you would want to design your experiment such that your power is close to 1 as possible, and level is close to 0 as possible. And there's a lot of literature around how do you choose power level, what kind of how do you fine tune your experiment around sample size and duration, and more specific details that I will not be covering, but I will be sharing a link to that at the end of this slide that you can refer to and go through that. So in this example, we take an example. Let's say you have a learning to rank algorithm that is presenting users with a ranked set of search results based on their search query, right? And then there is a baseline model that is already deployed in production, and now the machine learning team has come up with, let's say, two different variants called model A and model B, and they want to see if these models are performing better or worse than the baseline model. So what you would typically do is, and again, the numbers on the right hand side, these are example numbers. So you would, for example, have 95% of your users being served the baseline model, and then the remaining 5% user, you would divide them into the model A group and model B group. And when these users make these search queries, right, so you associate a search session, right, and the session is your user plus your query. You would typically create a unique identifier for each query. So it will be your user ID or some sort of an ID, which is again a proxy for a user if the user is a logged out user, along with the query ID. And there is optional a time window. Sometimes people would want to restrict search duration or search session by size, because if you are searching for something today versus if you are searching for the same thing after 2 months or even tomorrow, the context could change completely, right? So sometimes it's used, sometimes it's not. So you define some sort of a search session, right, and then you associate UUIDs with each of these sessions to be able to mark them individually, and you split them up. And once you have presented these users with results from model A and model B, you would continue gathering the downstream analytics of how the user is interacting with those search results or those recommendation results or any other results that we are serving them, right? And over a period of time, let's say if you run this experiment for 4 weeks, at the end of 4 weeks, you will have a very clear metric. For example, if your metric is to increase the time spent by consumer on your website by browsing and engaging through more content, that is the metrics you would look at. And if you observe that model A is performing better than baseline and model B, and model B is, for example, performing worse than the baseline, then you know that you can eventually start rolling out model A to more number of people going forward. So this gives a very good way to test out your models without actually worrying about any catastrophic impacts, because sometimes if your model is worse than your baseline models, and those things might not be taken very good by your end consumers or the business processes that you're working for. And sometimes you would want to do some incremental changes. So for example, if you want to drive the conversion from, let's say, 10% to 15%, you might build a model that slowly increases it from 10% to 11%, run this experiment, and then again reiterate on this model to move the needle from maybe 11% to 12.5% and so on. And then over a period of time, you finally have a model that is able to make the conversion of 15%, which was the desired objective here. Now, when it comes to defining your architecture, the software architecture around how A/B testing is done, there are really two ways to do it, right? And the diagram is about the second and the better way, but I'll also speak a little bit about the first and a more rudimentary way, right? So what happens is, let's say in a typical web application, you have these model view controllers, right? And you typically write your code to serve something inside the controller. Now this logic of separating out the users and into different groups and serving them different result can be written in a specific controller, right? But the issue or the challenge there is that this every time you have to perform an experiment, there has to be a dev change, a code change that needs to go through. Plus, if there are more number of product features where you would want to run this experiment, then you will have to make those particular changes at each of those code places. And that's a lot of redundant code, and that increases a lot of chances of bugs, right? Not to mention that this also increases the time to make an experiment, because the product team now needs to for example, raise a Jira issue to the engineering team, and then they will work on it, make this change happen, and then it will go live, right? So that is definitely one way. It works if you are a very small team, maybe 1 or 2 developers doing it, it works great, right? But if you are a larger team and you are working in a more structured organization, the right approach is that you build some sort of a framework that is able to perform A/B testing at a level which is one layer above your standard application level. So what it means is that regardless of what application, what module, what feature are you trying to A/B experiment with, the product team has a more control on what groups they can set up, how long they can run this experiment for, when they want to shut it down, and so on and so forth. The dev team is simply responsible for shipping out those features and ensuring that these features work correctly with the so-called feature flags or the experiment that the product team is wanting to run. So in this example, you can see that there are these 2 models, A and B, and they both are being served via a different microservice, for example. And then you have your application, which is one layer above your actual models, and this application is responsible for routing the requests coming from the users or their mobile devices into the control group or the baseline group, and then serve the results appropriately. So this is usually a better way to implement such sort of a system. But like I said, depending on the environment and the application on which you want to run A/B testing, this itself, creating this framework might be something very easy, or it could be a very complex task. So typically you have to take your own call when you are faced with this situation, that hey, is it quicker for me to, for example, just do A/B testing on this one feature, because this is the only feature that we are going to, let's say, perform A/B test in next couple of months. But if you are thinking of it more from a general product perspective, and you are also taking into account your UI UX A/B experiments along with your data science A/B experiments, then building those kind of models building those kind of frameworks is relatively more difficult. So yep, that's all about A/B testing. Hopefully now you have a better understanding of how do you incrementally push out your models to customers and measure these small impacts and prepare your models for release to the larger audience. Thank you.